equivalent conductancy. The equivalent conductancy, it is indicated with the lambda. Then how can you define the equivalent conductance? So it is defined as the conducting power. See, the conducting power of all the ions is produced by the dissolving 1 gram of equivalent weight of an electrolyte in a solution. So that conductancy power it is known as equivalent conductancy. So it is represented with lambda series. Then how can you write the mathematical equation for the equivalent conductance? So here the lambda is equal to K into 1000 by C. K into 1000 by C. So where here C means molar concentration, K means electrolytic conductivity. Electrolytic conductivity means it is nothing but a specific conductancy. K means here kappa, that means specific conductance, or it is known as electrolytic conductivity. So this is a mathematical equation for the equivalent conductance. So once again, the lambda is equal to K into 1000 by C. Then what are the units? Units for the equivalent conductance. So from the equation, lambda is equal to K into 1000 by C. Here K means electrolytic conductivity or specific conductance. What are the units for the specific conductance? Yes, we know that the units for the electrolytic conductivity or specific conductancy, it is ohm inverse, centimeter inverse. So these are the units for the electrolytic conductivity. And the volume, here we are taking the volume of a solution. What are the units for the volume? That is centimeter cube. And C means here the concentration. Here we are taking the concentration in terms of gram equivalent weight. That's why we are writing the gram equivalent weight. So finally, we can get the units for the equivalent conductance. So here, 1 centimeter, here in this 1 centimeter is cancelled. So remaining centimeter square is there. Now take it outside, then we can get the gram equivalent weight inverse. Hence, what are the equivalent conductance units? The units for the equivalent conductancy is finally ohm inverse centimeter square into gram equivalent weight inverse. So these are the units for the equivalent conductance. So next one, so that is molar conductance. Molar conductance. So molar conductance, it is denoted with the mu. It is denoted with the mu. Then here, how can you define the molar conductancy? So it is very similar to the equivalent conductance. Then how can you define it? So it is dependent on the conducting power of all the ions which are produced by the dissolving. See the difference. 1 mole of an electrolyte. 1 mole of electrolyte in a solution. So that conducting power, it is known as molar conductancy. So the mainly the difference between these two conductance, so that are molar conductance and equivalent conductance, it is a different is the weight of the electrolyte is a different. Here it is a 1 mole of an electrolyte. Here we are taking the 1 mole of a electrolyte. This is dissolved in a solution. So in the previous case, so that is in the equivalent conductance. So we dissolving the 1 gram equivalent weight of a electrolyte. See the difference between these two, then you can easily understand. Then how can you write the equation for the molar conductancy? So mu is equal to K into 1000 by C. Here it is a mathematical equation for the molar conductancy. Mu is equal to K into 1000 by C, where C means molar concentration. You know that. K means electrolytic conductivity or specific conductancy. You know that. So finally, what are the units? What are the units for the molar conductancy? So from the by using this equation, then we can easily find out the what are the units for the molar conductance? So from the equation, what is that? Mu is equal to K. K means specific conductance. We know the units for the specific conductance. So there are ohm inverse, centimeter inverse, and volume centimeter cube. Concentration, here we are taking concentration in terms of moles, 1 mole. So that is why we are writing the mole. So here 1 centimeter, in this case 1 centimeter is cancelled. So remaining what are there? Ohm inverse centimeter square into, take it upside, and what happen? Mole inverse. So these are the units for the molar conductancy. So finally, so these are the important definitions. And anyone in your examination, so they will ask all the definitions. So like what are conductancy, resistance, and specific conductancy, and equivalent conductance, molar conductance. So these are the very important for your examinations. Next one, variation of conductance with dilution. Variation of conductancy with dilution. So here, when you increase the dilution, then what happens to the specific conductivity? The specific conductivity is decreases here. The decreases on dilution. Decreases on dilution means directly proportional. So simply you remember that the dilution, it is indirectly proportional to the specific conductivity. Next one, what happened to the equivalent conductivity? Equivalent conductancy is increases with dilution. With dilution. And reaches its maximum value. When you increase the dilution, then what happened to the equivalent conductancy? The equivalent conductancy is also increasing with increasing in the dilution. Then what is the relationship between present equivalent conductance and dilution? So it is directly proportional. So remember like that. Okay, then next one, what happened to the molar conductance? The molar conductancy is also increases with increasing in the dilution. So in these two cases, that is equivalent conductancy and molar conductancy, it is increasing with the increasing in the dilution. So this is because of, if you dilute the any electrolyte, it will dissociate into maximum level. So that is why they will give the more number of ions. Hence, there is increasing in the conductancy power. So that is why while dilution power increases, so there is increasing in the equivalent and molar conductancy. Then what happened to the specific conductance? See this one. If you increase the dilution, there is a decreasing in the specific conductancy. Okay. So this is why. Why? Because see here. So when you observe that, when the specific conductancy of a solution in the conductance due to 1 centimeter cube of the solution. See this one, 1 centimeter cube of the solution. For example, so this is a 1 centimeter cube. Let it a 1 centimeter cube. The specific conductancy, it is depending upon the number of ions which are present in this area only. In this area only. The specific conductancy, it is depending upon the how many number of ions present in this 1 centimeter cube, 1 centimeter cube of a solution. So here the number of ions increasing in this area, then automatically there is an increasing in the specific conductancy. If there is a decreasing, less number of ions present in this area, then automatically there is a decreasing in the specific conductancy. So remember, finally you remember that the specific conductancy, it is depending upon the number of ions which are present in the 1 centimeter cube of a solution. So next one, that is degree of dissociation. Degree of dissociation. So degree of dissociation. So it is indicated with the alpha. Degree of dissociation, it is indicated with the alpha. Then how can you define the degree of dissociation? So it is a very simple. The ratio of the Equivalent conductance at dilution B, so that is indicated with the lambda B. To the equivalent conductance at infinity dilution, see the infinity dilution that is indicated with the lambda infinity. It gives the degree of dissociation. So alpha is equal to gamma lambda V by lambda infinity, or it is, you can write it as lambda C by lambda infinity. So that means when the dissociation is completed, that means when 100% is completed, then what happened to the degree of dissociation? Degree of dissociation become alpha, it is become 1. Why? Because when the dissociation is complete, means 100% dissociation is there, then what happened to the lambda V? Lambda V, it is automatically equal to lambda infinity. So if you substitute the lambda V as a lambda infinity, then lambda infinity is cancelled. Then what is the alpha value? Alpha becomes 1.